Hello guys, in this tutorial I will show you how to make this animation in geometry nodes. First of all, I want to say that I made this inspired by the tutorial of air curves from Wiresoul Studio. The link to that video is in the description. I decided to make a tutorial about this because that tutorial is about animation nodes, a really powerful add-on that was created before geometry nodes, and I wanted to prove to myself that geometry nodes are just as powerful as animation nodes. First, I will show you the complete node tree. Then I will explain how I made the earth model. For the earth model, first add an icosphere with a subdivision of 5. Change to edit mode, select all, and make an UV sphere projection with direction aligned to object. Create a vertex group and name it as you want. Then add a geometry nodes modifier. In geometry nodes, add a subdivision surface node with level 2. Add a store named attribute node with the same name as the vertex group. Add an image texture node with the image of the world map. You can find the link to the image in the description. Add a named attribute node with data type as vector and choose the UV map in the list. Connect it to the image texture node. Connect the alpha tone interpolation domain node with data type float and domain face corner, and connect it to the store named attribute node. Add a mask modifier. Select the vertex group, check mark smooth and change threshold to 0.2. Add a solidified modifier with thickness of 0.03. Convert the object to mesh and add a new geometry nodes modifier. In geometry nodes, add a distribute Poisson faces with distribution method as Poisson disk and distance minimum 0.2. Add a position node connected to a vector math node with length operation. Add a math node with greater than operation and threshold 0.99. Add an interpolation domain node, float data type, face domain, and connect it to selection. Make instance of simple curved lines on the points, add a realize instance node, and connect it to a set position node. Add an endpoint selection node, start size 0 and end size 1. Add a sample index node, vector data type, and point domain. Connect the points to geometry and the output value to the set position node. Connect a position node to value, add a domain size node with point cloud component and connect the points to geometry. Connect it to a math node with subtract operation and value 1. Add a random value node with integer data type, minimum 0, connect the subtract node to maximum and connect the output value to sample index. Connect the set position node to a resample curve node with count 3. Connect it to set position node, add a position node, connect it to a vector math node with normal as operation and connect it to the set position node. Add a resample curve node with length mod and length as 0.03. Connect it to a set position node and connect the vector math node to the position input. Connect the set position node to other set position node. Add a vector math node with a scale operation and connect it to offset. Connect the position node to vector, the factor from a spline parameter node to scale, and a float curve in between. In the curve, change the y values of the points to minus 0.02, create a new point in the middle with x value as 0.5 and y value as 0.25. Combine the length from a spline length node with a multiply node and control it with other multiply node. Connect the set position node to a trim curve node. Add a scene time node and a random value node with minimum 0 and maximum 15. Combine them with a subtract node and connect it to the start and end input from the trim curve node. Use a subtract node with value of 1 in the start input and a divide node with value of 15 between the frame and subtract. Connect the string curve node to a store named attribute node with color data type, spline domain, and call name. Connect the color ramp node to value with constant interpolation, and connect the random value node to factor. Connect the store named attribute node to a curve to mesh node, add a curve circle node with radius of 0.01, and connect it to profile curve. Combine the geometry from a group input node with the curve to mesh node using a join geometry node. Add two set material nodes before the join geometry node and select the different materials for each geometry. The store named attribute node is not necessary. I just use it to control the colors in the viewport. Well, this is the end of a really long, quick explanation. And if you are still here, that means you want more details about all of this. So first, I will start by explaining what is a vector, because I use a lot of the characteristics of vectors in this tutorial. Vectors can be described in different ways, but for simplicity, I will describe them as coordinates in a three-dimensional space with direction and magnitude. Oh yeah! The direction is determined according to the position of the vector in relation to the coordinates 0, 0, 0. I will call these coordinates origin, and the magnitude is equal to the distance between the origin and the vector. The section point on faces is really simple except for the selection. Here I use the magnitude or length in the vector math node to select the faces where the points will be generated. Because we use a sphere with a radius of 1 to create the air model, each point of the outer faces are approximately 1 unit away from the origin, and each point of the inner faces are less than 1 unit away from the origin. We use the interpolation domain node to change the selection from points to faces. This way, we avoid the creation of points in faces that are between the vertices with values of 0 and 1. Intersection straight lines, we instance simple lines that only have one starting point and one ending point. The realize instance node transforms every instance into individual objects that we can change. We use the endpoint selection node to select only the ending point for the set position node. The sample index node retrieves the position of the points to change the position of the endpoints. The index input is used to choose the value that is outputted from the field. The domain size outputs the total amount of points. We subtract this number by 1 because the index starts from 0. That means that the last index is always going to be the total amount of the field minus 1. And finally, the random value node is used to give a random position to every endpoint. I will use only one line to show how the section curve lines works. The example curve node with count 3 is used to create a point in the middle of the curve. The normalize operation in the vector math node changes the magnitude of every point to 1 without changing its direction. The example curve node with length 0.03 creates a lot of points in the curve that we normalize again. Here the obvious question is, why are we resampling and normalizing the curve 2 times? Why don't we just do it once? Especially when the result is pretty much the same. Well, this is because when the line gets close to the origin, the points from the resampling are not evenly distributed after the normalizing, which ends up creating a distorted curve. We avoid this by creating a middle point that stays 1 unit away from the origin. So, unless the position of the middle point is exactly the same as the origin, this will always work. But if this happens, then just change the seed of the distribute points on faces node or the seed of the random value node. In the section arcs shape, I use the direction and magnitude of each point to offset their positions. The scale operation let me control the magnitude of the offset. The factor gives a value from 0 to 1 to each point. The float curve node changes the input values depending on the shape of the curve. I use the length of each curve to multiply the scale. That way, the longer the curve, the stronger the effect will be, and use a multiply operation to control this if necessary. In the section animation, the trim curve node makes the effect. Divide by 15 the frame information so everything takes 50 frames to complete. Subtract by 1 so the second part of the animation starts the exact moment the first part ended. And finally, subtract random values so every curve have a different start for the whole animation. In the section colors, I use a store named attribute node with color data type to save the information as colors, and the spline domain saves one value per curve. We use the attribute name col so the information gets stored in the vertex color attribute. That way, we can use the attribute for the material and see the colors in the solid view. We use random values from 0 to 1 because the color ramp only uses values from 0 to 1. We change the interpolation to constant so the color ramp can only choose between the exact colors that we want. In the section Mesh and Materials, there's nothing complicated. You only transform the curves to mesh, join the original geometry, set the materials, and the store named attribute node is optional. It's not really necessary at all. I just use it to control the colors in the solid view. Well, this is the end of the tutorial. This took me a lot longer of time than I thought it would, so I hope you like it. Subscribe to know when I upload the next video, which I hope is really soon. Take care and see you later.